Penicillin is a type of antibiotics that derive originally from common mold known as penicillin molds. This type of mold can be found in decaying vegetation, soil and air. An example of this mold is Penicillium chrysogenum that perfectly treated the infections caused by bacteria.
This miracle drug is accidentally discovered by a lab technician called Alexander Fleming in 1928. After returning from a 2-week vacation, he discovered a grown mold on an accidentally contaminated Staphylococcus culture plate that prevents its growth. However, he stopped his findings in 1931 since he failed to extract and purify it. There is no progress for almost a decade until the research continued by Howard Florey and Ernst Chain with their Oxford team, since Chain is able to purify the penicillin. They conduct tests to test its efficacy and publish its findings. On 1940, British pharmaceutical companies are interested in mass-producing penicillin. However, due to the War of Britain, they are overburdened by the demand of other drugs. Florey turned to US and penicillin project is given a priority due to Japanese attacks on Pearl Harbor, causing them to develop a new method to generate greater amount of penicillin compared to Florey's method. By 1944, 73,000 of US troops is saved by these miracle drugs.
This is the classes of antibiotics such as beta-lactams, aminoglycosides, chloramphenicol, and others. Penicillin falls under beta-lactams class due to having a beta-lactam ring in its structure.
The basic chemical structure of all penicillins consists of a beta-lactam ring, a thiazolidine ring, an amide group, a carboxylic acid, and an acyl amino side chain. Antibacterial activity of the penicillin lies within the beta-lactam ring, and it could be broken by an enzyme called beta-lactamase produced by a penicillin-resistant bacteria. R represents a variable side chain of penicillin and varies depending on its type and is responsible in determining the pharmacologic properties of the compound.
There are many types of penicillin, but the most common are phenoxymethylpenicillin, flucloxacillin, and amoxicillin. Due to the different group attached to the NH, it differs the function.
Penicillium mold comes from Penicillium chrysogenum sp, which is preserved as lyophilized spores which produce the antibiotic penicillin. This spores is put into vegetative medium supplied with carbon and nitrogen sources and phenylacetic acid as a precursor under a pH of 6.5. Once the spore starts to germinate, producing vegetative body, mycelium, one part of the fungi, starts to form. Next, this fungi is then put into deep fermentation tanks with temperature of 25 to 27 degrees Celsius since penicillin productivity is the highest at this temperature. After some time, scientists separated the penicillin product from the mold. It is extracted by cooling the penicillin and filtering it using butyric acetate in the temperature of 0 to 3 degrees Celsius. Finally, penicillin is purified for the use as an antibiotic medicine.
In order to understand the penicillin mechanism of action, we need to know that cell walls in bacteria are made up from strands of peptidoglycan that consist of amino acids and sugar, NAM and NGA, through process transpeptidation by transpeptidase. Penicillin works by interfering cell wall formation by inhibiting transpeptidase that are responsible for catalyzing cross-links in the cell wall. When beta-lactam ring is in contact with the cell wall of bacteria, the ring opens and binds irreversibly to an enzyme called beta-lactamase and forms beta-lactam ABs that inhibits the cross-linking in the cell wall. The strain inside the penicillin will enter the bacteria along with water. Osmotic pressure inside the cell increases, thus the bacteria burst and die.
Penicillin has only one but very important role in our life. Thanks to it, the number of deaths during World War II is reduced. It serves as our net during bacterial infections such as streptococci and listeria. Also, as stated in encyclopedia.com, quote, the creation of sulfas and penicillins that created the pharmaceutical industry, one of the largest and most profitable industries in today's world, unquote. However, more bacteria are becoming resistant to antibiotics, including penicillin, making bacterial infections such as TB more difficult to be treated. This is why researchers have to continuously conduct research in order to fight this crisis in the cusp of this post-antibiotic era.